Hello, my name is Jorge Ciprian. I will be presenting the paper Assessing the Impact of the Loss Function, Architecture and Image Type for Deep Learning-Based Wildfire Segmentation, in collaboration with Dr. Gilberto Ochoa and Dr. Lucy Rossi. The objective of the project is to evaluate 3 state-of-the-art architectures, loss functions, and 4 image types that are visible, near-infrared, or near, and fused images from 2 different methods to identify the parameters that have the most impact on wildfire segmentation performance. We also identify the best performing combination and benchmark it against traditional fire segmentation methods. For the source images, we employ the Corsican Fire database. So we have 36 combinations of architectures, loss functions, and image types, and we use 3 evaluation metrics, the MCC, F1, and Hafian scores. We group the results by parameter, and we also obtain the Pearson correlation matrix to identify the parameters with the most impact on the performance. Then we also identify the best combination and compare it with the best traditional method found by Toulouse and colleagues. Here we can see the results. We can see that there is a significant difference in the results according to the different architectures and loss functions that you use. In particular, we can see that the Aglofi architecture and the focal traversal loss display the best results. And in contrast, we can see that no matter the image type you use, there is a very little difference in the results, with only a small advantage for visible images. We can also see that there are architectures that have strong correlations to the evaluation metrics, and in contrast, the 4 image types have very, very weak correlations to the segmentation performance. And the best combination that we choose is the Aglofi architecture, the focal traversal loss and visible images, and we can see that it outperforms the best identified traditional method. So in summary, we evaluate 3 state-of-the-art architectures, loss functions, and 4 image types to identify the parameters that are most relevant for wildfire segmentation performance. So the best combination that we found clearly outperforms the best identified traditional method. We can also see that the Aglofi architecture and the focal traversal loss displayed by far the most robust results. And in contrast, the image type appears to have a very little influence in the segmentation performance. So also the presence of color in the images shows little influence on the performance, in contrast with traditional methods, in which color is one of the most important factors. Also, near and fused images have the potential to provide a more significant advantage on more challenging images, which would be images with more smoke occlusion, for example. Thank you.